Hello, 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 everybody. Thank you so much for joining me. I'm going to be looking at another one of the Manitoba Math Contests in this video. Well, this series of videos. Specifically, I'm going to be starting the 2016 MMCs. So let's take a look. If you'd like a copy, click the link in the description, as with most of my contest videos, and you'll get a copy for yourself. But let's take a look. So we have the usual stuff. Always try and read for the start of your contest. 2 hours, and no calculators are allowed. There's a lot less reading here for some other contests. Lovely little pictures for the sponsors. I do like to make note, there are very important people out there, very important societies and groups sponsoring math competitions, and they should rightly be recognized. We got the Winnipeg Actuaries Club, Manitoba Association of Mathematics Teachers, of course the University of Manitoba, they're the ones who make it up, and the Canadian Mathematical Society. You'll find that they're behind just about every math contest made in Canada. Okay? But let's get right into it. We didn't come here to appreciate these sponsors, the people who help get these things made. We came here to practice. Hopefully you're practicing for an upcoming math contest. Maybe it's this year's MMC. Who knows? But question 1A. What is the sum of the digits in the number n is 2 to the 8, 5 to the 4? Okay. So, these bases here are not chosen arbitrarily. No. 2 and 5 are very special in that 2 times 5 is 10, and when you have a factor of 10, you basically just shift everything over and add a 0 at the end. So, if you add a 0 at the end, what are you going to do? Well, that 0 is not going to contribute to the sum of the digits. Okay. So, as long as we pick out all the factors of 10, we'll get all those zeros at the end, and they won't contribute anything. We'll just be worried about what's left over, and we'll add up those digits. And it will be a power of 2, we can see, just because there are more 2's than there are 5s. So each 2 is going to have a 5, each 5 is going to have a 2, and then there's going to be some 2's left over. So let's get it started. We'll open up our contest paper. Oh, I'm still, from a previous recording today, still using different colors. Silly me, always need to check that before I start things off. N is 2 to the 8, 5 to the 4. Okay. But this is 2 to the 4, 2 to the 4, 5 to the 4. You can break this 8 into 4 plus 4. So this is 2 to the 4, and then we can do 10 to the 4. So 2 to the 4, followed by 4 zeros. Well, what's 2 to the 4? Why, it's 16. So 16 followed by 4 zeros. The sum of those digits is 7. Okay? And I think we've explained what we do. We grouped it, powers of 10. That's how we know we can do the 4 zeros. It's question 1. Not a lot else that we should be writing there. So that's A part, not too bad. B part. Find the largest 3-digit number divisible by both 5 and 6. Okay. So, if D is divisible by A and B, this is a nice little math fact that we're bringing out, then D is divisible by the lowest common multiples, or the lowest common multiple of A and B. Okay? And this is actually true both ways. If you're divisible by the LCM, then you are divisible by both A and B. So we can, instead of having an if-then, we can do an if and only if, or the double arrow statement. Now the lowest common multiple of 5 and 6 is not that hard to work out. It's 30. If you want some more explanation, of course you could write out numbers, just start crossing them off. Another thing to do, 6 is 2 to the 1, 3 to the 1, 5 of course is 5 to the 1. The lowest common multiple, you just take the highest powers of 2, or the highest prime powers that you can find. So we'll have, technically this is 5 to the 0, and there should be a 2 to the 0, 3 to the 0 here. So we do 2 to the 1, 3 to the 1, 5 to the 1. This is another nice way to calculate the LCM, but not required. I would say you say lowest common multiple is 30, you're all set. So what are we looking for? Well, to find the largest 3-digit multiple of 5 and 6, really what we're looking for, the highest 3-digit multiple of 30, and really there's not a whole lot around this. It's 990. I suppose if you wanted to, because if you're one of those people who says, well, they say a numerical answer doesn't count, I got to explain it. If this wasn't enough explanation, I suppose what you could do is divide by 1,000, the smallest of the 4-digit numbers, divide that guy by 30, and you'll get a 3 here, you get 90 there, 10, bring down the, you get 3.333. So 30 times 33 equals 990 is highest such number. But really, I think once you realize multiple of 30, saying 990, it should get it to you. It's question 1. There's not a whole lot to do. 990. Put a little box around it, put a therefore statement, do whatever you like. But that's question 1. We're off to a great start. Question 2 will be in the next video. I hope you guys will join me there. I do encourage it. And try the rest of the contest on your own before proceeding. Find out what your weaknesses are, what your strengths are. And if you are writing a Manitoba Math Contest this year, I do wish you good luck. And hopefully these videos will help you refine your techniques, help you better prepare and practice for the upcoming competition, or really just any upcoming math competition. It's all fine. So thank you for watching, and I'll see you guys next time.